Hello guys, welcome back to Mason African Motives, still on our mathematics for grade 10. In this case, we shall be actually focusing on the introduction of our trigonometry, working with the trigonometry and also talking about the right angle, the triangles, where we shall be actually focusing about the trigonometric ratios and also the application of our Pythagoras theorem so that we fully understand this part of trigonometry in our level of grade 10. All right, so this is what we are going to have, guys. We've got trigonometry. All right, so let us see what we are going to have in this case. Let us consider a condition of having calculation of sides, calculation of angles, on triangles, or even the graphical presentation, like for an example, focusing on the right angled triangle, which is the major part of our syllabus, whereby we are given a right angled triangle like this. All right, the moment we are talking about an angle, this is simply a measurement that is between the two lines that we have. How are they separated? All right, so having these angles, which can be measured in degrees, or it can be actually measured in radians according to your angles. All right, we can have these angles in degrees or in radians, but as we shall be focusing mostly on the degrees so that we properly understand each other in this case. So given a right angled triangle, let us say we have got an angle that is inside of this triangle. Imagine this being x and this being y. Just imagine this being x, this being y, or this being m, all right? This being m or this being n. This is actually what we are supposed to have these angles presented. These are just letters that we can use to present our angles. But in our mathematics, we've got the angles that are so special that we are going to be using in these triangles or in presentation of angles in this case, all right? So we are simply saying our angles in trigonometry, all right? In trigonometry in this case, all right, these angles in trigonometry are usually, we are going to have a presentation of different angles, all right? So these ones, they are usually indicated or represented in terms of, all right, in terms of these letters, just like I was indicating M and N, but as we are not going to use the letters that we have in our alphabet, we are going to use the Greek letters in this case, right? So in terms of what? Of the Greek letters. And these Greek letters that we are going to be talking about, we are going to be talking about the one that we refer to as theta. So this simply represents theta. Theta, I don't know how you pronounce it, but that theta there. And you also have beta in this case. So this one, it's beta, all right? So you're gonna have our beta, and we also have alpha, all right? So this is alpha, all right? So these are just Greek letters or Greek alphabet, just like A, B, and so on, right? So these are just Greek alphabet. Then we also have phi in this case, all right? So this is phi, this is alpha, this is beta, this is theta. These are the angles that we can actually have used to be presented in terms of our, in terms of any angle that you might have in your triangle. So meaning to say they can represent this as theta, or they can represent this as beta, they can represent this as alpha. They can use any of these letters to represent the angles. These are the normally used letters that you're going to be having in your syllabus, or to represent the angles. Yes, we can use X, we can use M, but these are the major angles that we are going to have in our trigonometry. All right, let us consider, before we talk about the indication of the angles back into this triangle, because we shall talk about the angle. How does it affect the sides of your triangle? So before we talk about that, let us just have a recap of our Pythagoras theorem from our grade 9. Remember, we have this part that affects a right angle triangle, which is on the Pythagoras theorem, right? So we've got the Pythagoras theorem in this case. What does it refer to, and what is it that we are talking about on the Pythagoras theorem? We are referring to a right angle triangle just as usual, but this time we are not even worried about the angle that it is going to be here, or the angle is going to be here that we are going to be. We are not even worried about that. As long we have this right angle means 90 degrees. Whenever we see the right angle, it means we've got an angle of 90 degrees. So this is the most part that we are worried with. So take a consideration that you've got a triangle referred to as ABC. Let's say I've got a triangle referred to as ABC. And it follows that if this is angle A, the corresponding side to A is referred as the small letter a. The corresponding side to angle B, this side that is opposite to angle B, is referred as B. And the opposite side of angle C, the one that we have, is going to be referred as a small letter c, where this side that we have is referred to as the longest side. So this is the longest side that is opposite to the 90 degrees, because that is the biggest possible angle that we can have in a right angle triangle. The biggest angle that we can possibly have is the 90 degrees. So it follows that the side that is opposite the biggest angle is the longest side. So that longest side in terms of this Greek presentation is the one that is referred to as the hypotenuse. So that's where we have the word hypotenuse. Hypotenuse from the word longest. So we are simply referring to the longest side, hypotenuse, longest side. So it follows that from our Pythagoras theorem, this hypotenuse, which is the longest side in this case, the square of it is equal to the sum of the square of the two shorter sides, that is a squared plus b squared, whereby these a and b are the remaining shorter sides. All right. Remember, we said C is the longest side that we refer to as what? As the hypotenuse. So in case that this triangle was given now, because it might be a confusion if I change this, it means my formula is going to change. The moment I change this, maybe this is now A, this is B, this is now C. So it brings a big confusion now to us. How am I going to write these letters to maintain the formula of c squared is equal to a squared plus b squared? All right, do not worry about these letters that we see here. What is important is that the hypotenuse, which is the longest side, if you square it, it is equal to the sum of the two shorter sides. So that's why you see some write this formula in terms of h representing the hypotenuse. So they end up having this formula as h squared is equal to a squared plus b squared, whereby h represent the hypotenuse, a and b are the shorter sides that we have on our triangle. These are the shorter sides, a and b. Because you might have these letters interchanged, and you now wonder the formula has changed. But if you understand that a and b are the shorter sides, then h is the hypotenuse, you won't even go wrong on answering of this question. And it does not matter how the triangle is given. If the triangle is given this way, this is our 90 degrees, I know that this is the hypotenuse. The one that is opposite 90 degrees is my hypotenuse. And these two sides, one of these represents A and the other one represents B. So it does not matter that I'm going to take this as my A, I'm going to take this as my B, or I'm going to take this as my A, or I'm going to take this as my B. What matters is that I have the hypotenuse, which is the longer side that is opposite to the 90 degrees. So if you write this in terms of C and understanding that C represents the hypotenuse, it means here you're going to write it as a C. So what matters in this case is what represents the hypotenuse. Then the other sides, they are the shorter sides. So the order of the other sides does not matter how we are going to take them. So this is the formula that we can actually use to calculate any given side or whatever. All right, let me just read this. Let me just write this. For the Pythagoras theorem, we are going to be using this in calculating of sides. So this is actually in calculating of sides. Calculating of sides. So we are not going to have any condition of the Pythagoras theorem being used in calculating an angle. It only ends in calculating of sides when given two sides. You're going to calculate the third side. So that is the condition of your Pythagoras theorem. It only works on a right angle triangle. Take a consideration that you have a right angle triangle whereby this is 13 centimeters, this is 5 centimeters, and you're asked to find the value of x, which is the unknown value in this case. So this part, what is important, it does not mean that you're going to be given A, B, C, and so on. Even without the letters that are surrounding your triangle, know your formula. This is a right angle triangle, and I know that the hypotenuse squared is equal to the sum of the two shorter sides squared. So this is the hypotenuse C, the one that is opposite to what? To the 90 degrees. So the moment I know that this is a 90 degrees, so the C is going to be this, which is the hypotenuse that is 13 squared. So we are going to have 13 squared is equal to, then the part of A and B, we are just talking about any of these two sides that we have, any of these two. That is what we have in any order. So I'm simply saying here, we are going to take in any order that you have. So it does not mean that if I start with 5, I'm wrong. If I start with X, I'm wrong. Any order, that is your A. And so you can say, this is my A, this is my B, or you can put it another way. This is my A, this is my B, in any order that you want, right? So we are going to have A squared plus B squared, which are the shorter sides. So I'm going to take this as X squared plus B, which is this 5 squared. And also, do not use the units when writing here. This is 13 centimeters. You write as 13 centimeters squared, right? Leave these units. You know that the units are in centimeters. So at the end, your answer, you're just going to write in centimeters. So don't indicate the units when writing here, all right? So you can find 13 squared. That means 13 times 13. So you can use your calculator, but that is going to be 169, which is equal to x squared plus 5 squared, that is 5 times 5, which is going to give us 25 in this case, or you can just use a calculator to simplify. Then we can transpose this to the other side so that we can subtract to obtain the value of x squared. So that is going to be 169 minus 25 is equal to x squared, which is, if we subtract, that will be 144 is equal to x squared. So in order for you to have the value of x, you're going to determine the square root because this is a square. So to remove the square, you introduce the square root both sides of your equation, and that will give you the value of x here. So our x is going to be the square root of 144, which is actually, we know that the square root of any number is plus or minus. But here we are referring to x that is representing a side. So this is going to be a positive. You're going to take the positive value. Yes, there is a condition. We shall talk about that when you work with a Cartesian plane, where you can actually have your values as negative. If it is on this side, you can actually have your value as maybe -3, -4, and +5 like that. You can actually have a condition like that because you are in the negative region. But in this case, we are not on that Cartesian. So here you are taking every side as a positive. So you're going to take your x as a positive value, meaning to say our x here is going to be 12 centimeters. So what is important is know the formula to work with, then substitute on your formula. You can find whatever. If you transpose from the formula, it does not mean that if I have this formula, I'm supposed to also know the formula of b squared. I'm supposed to also know the formula of a squared. No, just know the one formula, then substitute your values in that formula that you know. So it does not matter the order or how the triangle is given. Like I mentioned before, what matters is that, are you having a right angled triangle? So you can have a condition, maybe we've got, in this case, 6 centimeters here, then we've got 10 centimeters, right? 8 centimeters here, sorry, that's 8 centimeters, and you're asked to find the value of x. So as we can see, this is a right angle triangle. We have got the 90 degrees, this one. So it does not mean that the 90 degrees is supposed to be on the base always? No, the 90 degrees can be given anyway. It can be given on a condition like this, where we are given a right angle triangle. This is 90 degrees. It can be given in any manner as long you see this sign. So that means this is our hypotenuse. The side opposite to the longest side is your hypotenuse. That is what matters. So this means this is our C, and the rest of the sides can be a B, can be our A. So that one does not matter. But what matters is that the hypotenuse squared is equal to A squared plus B squared, which are the shorter sides. This is the longest side, which is the hypotenuse, the one opposite to 90 degrees, which is our X in this case. So that means X squared is equal to A squared plus B squared. We've got A and B, which is in any order that you're going to take. So you can take this as 6 squared plus 8 squared, or 8 squared plus 6 squared. So that means you're going to have this as X squared is equal to 6 squared. That means 6 times 6, or on your calculator, that is going to be 36 plus 8 squared, which is going to give you a 64. So if you combine this, you are going to have X squared, which is equal to, add this, that is going to give you a 100, or you can just use your calculator at the same time on your simplification. If this part of adding and subtracting gives you a challenge, all right? But that is 100 there. So I just want you to see this part here, having our calculator, that is 36 plus 64, which is going to be 100. Then in order for you to determine the X, you introduce the square root. But like I said, we are referring to X, which is a side on a shape. You're going to take these values as positive. So there's no need for us to write the plus or minus this time, but that one was just for introduction. So we're going to have the square root of the answer, which is a 10 in this case, all right? So our X there is going to give us a 10. That is the side corresponding to the right angle triangle, where we have got the side of 6 centimeters, 8 centimeters. It means this will be 10 centimeters, all right, which is this side as our hypotenuse. So that is the application of your Pythagoras theorem. Just substitute into the formula and manipulate it for whatever that you want to calculate. It does not mean that always the unknown is the one that you have here. No, this C represents the hypotenuse. So know what each and every letter of your formula represents. So if you are to work with this part in your calculation, it is going to be very, very useful, because it is going to be used on some cases where you actually need the Pythagoras theorem. All right, but the purpose of this class, like I said, is to focus on the trigonometry of the application of angles. So we are still on our right angle triangle, but in this case, we want to talk about the trigonometrical ratios and how do we apply this in simplification. All right, so we also have what we refer to as the trigonometrical ratios. Trigonometrical ratios like this. All right, so we've got ratios like this. All right, so the trigonometrical ratios, these are the ones that we are actually taking from the mnemonics of SOHCAHTOA. Remember, from our SOHCAHTOA concept, we obtain the ratios that are corresponding, the ratio of sine, the ratio of cos. So we have what we refer as the sine, we have what we refer as the cosine, which in short we write as cos in short, and this sine in short. Then we have got the tangent. In this case, we've got the tangent that we refer as tan in short. All right, so these ratios that we see here, they can create other ratios which are the reciprocals of these ratios. But before we talk about how to use the ratios and how to write the ratio of sine, the ratio of cos, the ratio of tan, we now go back to the application of our right angle triangle with the use of these angles that we have here. How are they going to affect our right angle triangle? That is the question. These angles that we see, how are they going to affect our triangles? All right, so I want you to see what is going to happen with this application of our angles. If we are to take a right angled triangle in this case, all right, we are still on a right angle triangle. If you are to take a right angle triangle, then you indicate this angle as theta, like that. Let's say this is theta. Yes, you can have your sides, A, B, C, whatever that you have there, which is fine. But in this case, I want to talk about the exact naming of the sides that you have according to the angle theta. This angle here, it determines the sides that we are given. The angle that you are given here is the one that determines the side. So the angle determines the sides that you are given, all right? The sides of a triangle, in this case. All right, so for any given triangle that you are going to be given, this angle is the one that is going to determine your sides. So the first thing is this angle. As you can see, this side here is directly opposite to the angle. It is facing each other with angle. These two, they are facing each other. So that side is referred to as the opposite. So it's up in short, but you're supposed to have this as the opposite, like this. Then we have got the side where the 90 degrees angle and this angle theta here, they are on the same side. They are on the same side. So to be on the same side or to sit next to each other on the same side, it means you are adjacent to each other. So this side is referred to as the adjacent side. The 90 degrees and the angle theta, they are adjacent to each other at this point. So this is referred to as the adjacent, all right? So you can just write adjacent in short, or just adjacent, all right? Then this side does not change, whether the angle is given where or wherever the angle is given. The one that is opposite to the 90 degrees, remember the longest side does not change. That is our hypotenuse in this case. So there we have got the hypotenuse. So the hypotenuse does not change. It's always facing 90 degrees. It's always facing the biggest angle. Like I said, when you are given a right angle triangle, this is the biggest possible angle that you can have. These angles that you have will be smaller than 90 degrees, because remember, our angles should add up to 180 degrees. So the moment we take 90, it means these two angles here should add up to 90 degrees. So they are smaller than 90 degrees. All right, so this triangle that we see, it is not a matter of fact that the angle that you are given is the one that determines whatever that you have. Let's say you've got this triangle here, and this is where you are given your theta. Your theta is at this point. It means you are going to name whatever that you have according to the point where theta is. According to this theta here, this side is opposite to theta, right? This side and theta, they are opposite to each other. So there we have got opposites. I'm just going to write OPP for opposite in short, all right? So the theta that we have, which is our angle, and the 90 degrees on this side, they are adjacent to each other. They are sitting on the same line. They are found on the same line. So it means that is your adjacent. And like I said, the one that faces 90 degrees is always the hypotenuse. It does not change its position. So this is the position always for the hypotenuse, always facing 90 degrees. So as we can see, the theta that we have determines the angle. So it means if the theta was here, or if the angle was here, let's say we've got angle alpha here. According to angle alpha, this layout is going to change. According to alpha, this side is now opposite to alpha. According to this angle alpha, this side is now opposite. According to this alpha, this side is now adjacent, where 90 and alpha are found on the same line. So it's now adjacent to alpha. The hypotenuse does not change. So as you can see, the angle that you are given, it determines the what? The sides that you are given. So you are supposed to be very, very careful about the naming of your sides. Once you know this side, that this is going to be opposite, this is going to be adjacent, yes, you can use in terms of what we have in terms of A and B, which is fine to say, let's say this is my A, this is my B, and this is my C, this is 90 degrees, this is my theta, then I can use my ratios like that. But I want us to know in terms of the actual sides, how are they given? Opposite, hypotenuse, adjacent, according to theta. Know this because these are the ones that you are going to have on your formula. On this formula, there's no A and B. There is opposite, hypotenuse, adjacent. So you are supposed to know these terms, all right? So let us have our ratios. From this part. We are going to see that the ratio of sine of theta. So I'm just going to take my angle as theta. Remember, I said you can have your angle in terms of beta or whatever that you have here. So the sine of, I'm just going to use theta in this case. So it follows that the sine of theta is going to be given as opposite over the hypotenuse. So you're taking this formula opposite over the hypotenuse. Take note, opposite to the hypotenuse. So this is given as the opposite over the hypotenuse. So you can just write in full, just going to write in short. So we've got opposite over the hypotenuse in this case, all right? Or you can just write opposite over hypotenuse like that, which is the shortest way of presenting this part, all right? Then we move on to the cosine of theta in this case. This is cos, which is adjacent over the hypotenuse. So it follows that the cos of theta is going to be given as the adjacent, all right? I'm just going to write in short, adjacent over the hypotenuse like that, all right? Then we've got the tan of theta, which is opposite over the adjacent. So the O is for the opposite, right? So we are going to have the tan of theta being equal to the opposite over the adjacent in this case. So this is opposite over the adjacent. So these are the three trigonometrical ratios that we are going to talk about for the meantime. But like I said, we are going to have the reciprocals of these trigonometrical ratios. We have got the reciprocal of sine, of cos, and tan, having other trigonometrical ratios from there. But for the meantime, you're supposed to know this. And if you are to check now for the trigonometrical ratios that we have here, they are no longer limited, just like what we had on the Pythagoras. It was limited, but these ones, they are no longer limited. What am I trying to say? The trigonometrical ratios now can be used to calculate sides. It's either you're going to use this to calculate sides or you're going to use this to calculate angles. So as long you are given a condition where you have a trigonometrical ratio, you can use it to calculate whatever that you want. So I want you to memorize these mnemonics. That is the SOHCAHTOA concept. SOHCAHTOA concept. Sine, opposite over hypotenuse. Cos, adjacent over hypotenuse. Tan, opposite over the adjacent. But it must have an angle corresponding tan of theta, the cos of theta, or it is the sine of theta. That is how you are supposed to have this. So you are going to see even in another class whereby we shall be talking about solving of the trigonometrical equations, whereby now you have to find this theta. So we shall talk about that as we move on. All right, this is the first part that we are going to have here, where we are given exercise 1, the first part A, redraw the triangles below and indicate which sides are opposite, adjacent, hypotenuse with respect to theta. All right, so like I said, it does not matter that this is A, this is B. What matters is that you have the angle theta, and these sides, they are named according to the angle theta. All right, let us see this triangle, right? According to this triangle, as we can see, this one is facing theta. It's opposite to theta. So it means that is your opposite side. In this case, opposite to theta. They are opposite to each other. The one that faces 90 degrees, this is your 90 degrees. The one that faces 90 degrees does not change. It is our hypotenuse in this case. So we have got the hypotenuse in this case. And remember, theta and 90 degrees, they are sitting on the same line. They are found on the same line. So they are adjacent to each other. So this side, it becomes the adjacent in this case. They are adjacent to each other. That is how you're supposed to name this, all right? So you just have to redraw your triangle. And like I said, according to this triangle, it has to change, all right? According to this triangle, theta is opposite to this side. So it means this side is opposite to theta. So this is our opposite this time, all right? 90 degrees, it faces this side, and the side that always faces 90 degrees is the longest side, which is our hypotenuse in this case. So we are going to have the hypotenuse, and theta and 90 degrees, they are sitting on the same line together. They are on the same line, so they are adjacent to each other. So this is our adjacent. These two, they are adjacent to each other. So that is how we can name our angles, as long you understand this idea. All right, now we are given on B, that is, state the following in terms of G, K, and M. So we need to find these trigonometrical ratios, but in terms of these letters that we are given. All right, so whenever we are answering our trigonometrical ratios, we are going back to the idea of our SOHCAHTOA in that case. All right, so we are going back to SOHCAHTOA. All right, that is the sine of theta, the cos of theta, and so on and so on. All right, so the first one, question number one, we are given in this case, that was the sine of k. All right, this one is the sine of k in this case. All right, that is question one, the sine of k. So if you are to consider this is the angle k, according to angle k, remember I said the angles, the sides, they are named according to the angle. So according to this k that we see here, according to k, this side is the opposite. It is opposite to k. It is facing each other with k. So this is our opposite. The k, this angle k, and this 90 degrees, they are sitting on the same line, which means they are adjacent to each other. So this is the adjacent, and the KG, this one, is the one that is opposite, that faces the 90 degrees, and always that is the longest side, which is the hypotenuse, and it does not change according to the angle that you are given. This one, it always faces 90 degrees. All right, so let us go back now to the ratios that we are given. Remember, like I said, we are to find the ratio, and from our trigonometrical ratios, we understand that the ratio of sine is given as sine its opposite over the hypotenuse. So you can even write as O over H like that. That is opposite over hypotenuse, if you understand, or you can just write in short, that is opposite over the hypotenuse in short, or you can write in full, it's fine. All right, what matters is that what is it that you are referring to as the opposite? It's according to angle K. So according to angle K, we said the opposite is this small letter k. So it is going to be k, which is the small letter, over the hypotenuse. The hypotenuse in terms of m, that is m. All right, so that is we have the ratio of what? Of sine k. So it is the same scenario that we have on question number 2, because we are still using the same letter k. So the cosine of k in this case is going to be given as the cosine of k according to this part. If you are to consider the ratio of cos, it's adjacent over the hypotenuse. Remember, we wrote this, so that is the adjacent over the hypotenuse. So we are simply filling in our information. So the cosine of k, according to k, we said this is our adjacent, which is given as g over the hypotenuse, which is given as what? As m. So that's g over m. All right. Then we've also the tan of k. So from the same diagram, we need the tan of k in this case. All right. So the tan of k is going to be given. Remember our formula for tan, it is going to be the opposite over the adjacent. So there is opposite over the adjacent. So we are going to have the tan of k as the opposite over the adjacent. So that means we've got the opposite according to our diagram. All right. So according to our diagram, remember, this is our k and the opposite is k. The adjacent is g. So it's going to be opposite over the adjacent, which is k over g. That is opposite over the adjacent. So you're going to have the small letter k over g. So that is how you can play around the information that you're given. We are using the same letter k throughout here. That is why we are maintaining these sides. But the moment you check what is happening on question number 4, we are now referring to the angle G. It's now sine G. So this layout that we see here can no longer work because we name the sides according to the angle. So according to angle G, we are supposed to name our sides. So this does not work now. So we are going to remove this. Now we have another information unless for the hypotenuse, which does not change. So according to angle G now, this is our angle G. So we are now referring according to this angle G. What does this G represent? So this is the opposite. It faces each other with the G. So we are going to have the opposite, all right? The one that faces 90 degrees, like I said, does not change. That is our hypotenuse. And this side K, which is the one where the angle G and 90 degrees, they are found on the same line. They are sitting together on this line. So that is the adjacent side. You refer to that as the adjacent. So you name the sides according to the angle. Because you are referring to angle G, these sides, they are going to change. So that means in this case, the sine of G in this case is going to be given. Remember, we talked about the ratio of sine, which is opposite over the hypotenuse. The ratio is not going to change. So you're simply going to substitute opposite according to this G. This is now the opposite, which is G. You take it according to the angle. So the opposite this time is G over the hypotenuse, which is M. So it is going to be the sine of G is going to be G over M, all right? Which is the same thing on question number 5. We are still on the angle G in this case. So it is going to be the cosine of G according to angle G, this one, all right? The cosine of G is adjacent over the hypotenuse. That is our formula. So meaning to say the cosine of G, because we have our adjacent according to this diagram, according to this angle G, our adjacent in this case is given as K. So this is going to be K over the hypotenuse, which is M. So this is going to give us K over M. So that is how you can simply answer these typical questions. And the last question that we have on this is the tan of G. So as we can see, we've got our ratio. We're just going to apply our ratio in this case, right? So that is 6. So we're going to have the tan of G from which concept? Tan is opposite over the adjacent. So we're going to have the opposite over the adjacent. So we are simply substituting according to what we have here. According to G, the opposite is given as what? As G in this case is the small letter G over the adjacent, which is the adjacent in this case is K, all right? So as you can see, the answers that we have for G and what we have for K, they are different because the sides are named according to the angle. I mentioned that, so just make sure you revise through and understand this part like I was talking about, to say whenever you are representing the trigonometry, but this part, the sides that they are represented with respect to what? To angle, which is the theta, representing what? Which is the angle in this case. All right. Then we have got the same scenario in this case on this triangle, or on question number, say, like I said, the presentation of your triangle does not matter. What matters, or what is significant, is how your angles are given. So there we are given, state the following in terms of P, Q, and R, which is this small letter P, Q, and R. So we're asked to state the sine of theta, the cos of theta, the tan of theta. So there we are talking about the angle theta. So we are supposed to name our sides according to angle theta. This is our angle theta here. So according to angle theta, it follows that this is the opposite. It faces each other with theta. So this R here represents the opposite. According to this theta and the 90 degrees, they are sitting on the same line. They are adjacent to each other. This side becomes the adjacent, and Q, which is this side, is facing 90 degrees, which is the longest side. So that is going to be the hypotenuse, always facing the longest angle. It will be the longest side, which is your hypotenuse. So you name according to theta. So according to theta, this is how our angles are going to be. So as we know, the still concept does not change of our SOHCAHTOA. All right, our SOHCAHTOA concept is not going to change. So that means first part here, which is the sine of theta, is simply going to be opposite over the hypotenuse. So according to this, theta that we have, the opposite is r in this case. All right, so it's going to be r over the hypotenuse, which is q. So we are going to have r over q, right? Which is the same thing on number 2, which is the cosine of theta in this case. And cos theta, remember we said it's adjacent over the hypotenuse. So having adjacent over hypotenuse, which is according to this theta that we have, we said the adjacent is p in this case. So that will be p over the hypotenuse. Our hypotenuse is q. So it will be p over q. That is the same thing that we are going to have on the tan of theta in this case, on this question. So the tan of theta from our ratio being taken as the opposite over the adjacent. So you're going to take opposite over the adjacent, and the opposite in this case, according to theta, this is our opposite, which is r over the adjacent. Our adjacent is the side, which is p. So as we can see, you answer these questions according to what exactly you are given. So as you move on now to the question 4, to the question 5, to the question 6, you are going to see that there you are now using alpha, which is not theta. So it means this is going to change and it is going to affect our triangle. Our triangle can no longer be used the way that it was given, because remember I told you the sides are named according to the angle, which is the one that you are given. So now you are working with the angle alpha, alpha, and alpha here. So it means we are going to be focusing on the angle alpha this time. According to angle alpha, what is it that we have here on P? It is opposite to alpha. It is facing each other with alpha. So this becomes our opposite this time. All right. Alpha and 90 degrees, they're sitting together on this line. They are on the same line. So this line, it becomes the adjacent, and the one opposite, or the one facing 90 degrees, which is the longest angle, becomes the longest side, which is our hypotenuse, and this one is not affected. So guys, as we can see, because we are focusing on this alpha, that is why our sides have changed. If we were focusing on theta, it means this is going to change. According to theta, we saw that this was opposite. It was because we are referring to theta. But now we are referring to alpha. So alpha changes because it is now opposite to this side. So this side is now our opposite. Alpha and 90 degrees, they are sitting together on this line. So it is now our adjacent. But the idea of our trigonometrical ratios is not going to change in any calculation that we are going to have. So that means in order for us to have question 4, which is the sine of alpha in this case, we are simply going to have the same thing, the sine of alpha, which is the sine, it's opposite over the hypotenuse. This part is not going to change. All you just have to substitute is that according to alpha, the opposite is given as p over, all right, so this is just a small letter there, p over the hypotenuse, which is the hypotenuse is given as what? As small letter q. So that is what we are going to have. It is the same thing that you are going to have on question number 5, because you are referring to the same angle, which is alpha in this case. So meaning to say the cosine of alpha, according to the ratio, the cos is adjacent over the hypotenuse. So you're going to have adjacent over the hypotenuse in this case, which is according to our alpha, the adjacent there is r over the hypotenuse, which is q. So it's going to be r over q. So that is what you're going to have also for the tan of alpha. as long you have your ratios, all right? So that means we're gonna have the tan of alpha in this case as, remember, tan opposite over the adjacent. So this is going to be given as the opposite over the adjacent. So we are simply going to substitute our values. That is according to our formula. The opposite here is given as P over the adjacent, which is given as R. So it is going to be P over R. So as we can see, that is how we can have our questions answered. What is very, very important is for you to understand that the sides are named according to the angle theta. The angle theta is the one that you are going to use, or I mean the angle that you are given. It can be theta, it can be alpha, whatever angle that you are given there. It is the one that determines your sides. Let us check what we have on the D part. We are given triangle ADEF is shown with given dimensions. So these are the dimensions of the triangle. Determine the length of EF. All right. So we are now back to the Pythagoras theorem now to determine the length of what? Of EF. So remember our Pythagoras theorem from our introduction, I talked about this. If you're given a right angle triangle with two given sides, you can be able to calculate the third side, all right? Knowing that from our Pythagoras theorem, it states that the hypotenuse squared is equal to a squared plus b squared. So as you can see here, there is D, there is F, there is E. What is important, guys, is for you to understand what the hypotenuse represents. The hypotenuse, which is the one that we refer as C, is the one that faces 90 degrees. That is the hypotenuse. A and B, these are the shorter sides. Theta is not even in at this moment. Do not even focus about theta. We are only focusing on the sides. So the A and B are any of these two shorter sides. So I can even write this as EF squared, representing the hypotenuse, which is the longest side, is equal to A and B, any of these two shorter sides. So I can even write in terms of ED squared plus DF squared. I can just write in terms of whatever that I want, right? So I can just substitute my values because I have this part of ED, the part of DF. I'm going to use it to calculate EF. So that is EF squared is equal to ED squared. That is the value that we have in between this ED, which is 24 centimeters. So just square the number as it is 24 plus DF squared. That means is this side from D to F, which is 10 centimeters. So that is 10 squared. So we are going to obtain EF squared, which is equal to 24 squared plus 10 squared. So there you can just use your calculator at once to simplify the value, or you can find the value of 24 squared, the value of 10 squared, or you can just add at once. That is 24 squared plus 10 squared like this, which is going to give us 676. So you're going to have 676. You determine the square root so that you remove the square that we are seeing here. So you're going to determine the square root both sides. So you're going to obtain the length of EF. And that length of EF is simply the square root of the answer that we had, which is 26. So this is going to give us 26 centimeters according to what we are given. The units are in centimeters. So your answer is supposed to be also in centimeters. So you now have the value of EF, which is in this case 26 centimeters. All right. So from the value that we calculated here using our Pythagoras theorem, now they want us to use the same value to calculate the ratio or to find the value of sine theta, cos theta, and tan theta. So that's where now we apply our theta back to say this theta is now, we can use this theta now. And according to theta, what does it mean? Remember, our sides, they are named according to theta. We talked about that. Our sides, they are named according to the angle that you're given. So according to this theta, this side is the opposite. It is facing each other with theta. So we've got the opposite, all right? According to this theta, theta and 90 degrees, they are sitting on the same line. They are adjacent to each other. So this is the adjacent, and always facing 90 degrees, which is the longest side, is the hypotenuse in this case. So we can find the ratio of whatever that you're given, the sine of theta, which we talked about before from our trigonometrical ratios. Remember SOHCAHTOA from our mnemonics, we've got SOHCAHTOA in that case. So the sine of theta, which is opposite over the hypotenuse. So we are going to have this as the opposite over the hypotenuse, which is, according to this theta, your opposite is this side, which is 10 centimeters over the hypotenuse, which is 26. So you can even leave your answer like this, or you can even write in simplest form 10 over 26 from your calculator. You can even write that in simplest form, that is 10 over 26 like this, which is going to be 5 over 13. So you're going to obtain 5 over 13, or you can even write that as a decimal, but you can just leave it like that as a fraction, which is the best way of presenting this answer. All right, then we move on. The cos of theta, we also need from the same triangle, the cosine of theta. So as we saw that from our ratios, the cosine of theta being the adjacent over the hypotenuse, we're going to have the adjacent over the hypotenuse in this case. That means the cosine of theta will be taken according to this theta. We said this is our adjacent, which is 24 over the hypotenuse, which is given as 26. So this is going to give us the value of cosine of theta, which you can write in simplest form. Again, just like the previous case, we can simplify this 24 over 26 like this, which is going to give us 12 over 18. So this will be 12 over 18. So that's how you can have your values simplified. And the last part here is the tan of theta. So you can also go back to your ratios and simplify for the tan of theta in this case, which we said is the opposite over the hypotenuse. So you're going to have the opposite over the adjacent. I mean, that is opposite over the adjacent. So that means the tan of theta is equal to, according to this theta, our opposite, which is 10. So that is going to be 10 over the adjacent, which is 24. So it's going to be 10 over 24, or you can have this in simplest form. That is the tan of theta in simplest form from our calculator. We are going to have this as 10 over 24 like this, which is 5 over 12. So this can be given as 5 over 12 in what? In simplest form. So as you can see, these are the values that you're going to have for the sine of theta, the cosine of theta, and the tan of theta from the diagram that we are given in this case. So as you can see, like I said, you name your sides according to the angle that you are given. And you can use your mnemonics, which is the SOHCAHTOA concept, to determine whatever trigonometrical ratio that you're given. Is it for tan? Is it for cos? Is it for sine? So this is the same concept that you're going to see being applied throughout, and also sometimes having the application of the Pythagoras theorem in calculation of the third side when you are given two sides. Like in this case here, we are given to determine the value of the following from this triangle. We need the sine of n, which is n is this angle here. Remember, according to the angle, this side becomes your opposite. So meaning to say you have the opposite, the hypotenuse always facing 90 degrees. So this is the hypotenuse, and this becomes our adjacent, the one that the angle and the 90 degrees are found on the, so that's our adjacent. So as we can see here, in order for us to have the value for the sine of n, it means we needed, or because you have this part of your SOHCAHTOA, remember that it means we needed the opposite over the hypotenuse on our ratio. So we are going to have this as the sine of n is the opposite over the hypotenuse in this case. But as we can see on our diagram here, we are now limited on the diagram because we do not have the value of opposite, which is BE. So you are now limited. That's where the Pythagoras theorem place a role to calculate the sides. You are no longer focusing on any angle that you're given. You are just focusing on the two sides given. How can I calculate the third side? Remember, we stated that the hypotenuse squared is equal to the square of the two shorter sides, the sum of the square of the two shorter sides, the hypotenuse squared. So the hypotenuse being the longer side that is opposite to 90 degrees, which is 17 in this case, right? So we are going to have this as 17 squared is equal. Remember what I said, A and B, these are the shorter sides. So whatever that you're going to take, or whatever order that you're going to take, these are the shorter sides. We say this is our hypotenuse, is already taken. The shorter side is going to be these two sides that are remaining. In this case, we have got the side of what? Of BE, which is our opposite there. So we're going to take this as BE squared plus, we also have this shorter side of 15. So it is going to be 15 squared. So just for the sake of simplification, so that you avoid errors, just simplify the square of 17. The square is 289. So 289 is equal to BE squared plus 15 squared in this case, which we simplify 15 squared, that is 15 to the exponent of 2, which is 225. So this will be 225. We can transpose this to the other side so that it becomes a negative. So we are going to subtract in that manner 289. So it's going to be 289 minus this 225, which is going to give us 64. So that's 64 is equal to BE squared. So to determine the value of BE, just need to find the square root in that case. All right, so the square root of 64, which is going to be 8 in that case, right? The square root of 64, which is 8. So 8 is equal to BE. Yes, we know that the square root of any number is plus or minus, but in that case, we are referring to a side, and on a shape, like I said, you're going to only use positive values, all right? Unless you're talking about a Cartesian plane where we are going to use negative values depending with the side that you are given. So this is how you were going to calculate the side representing our opposite. Once this side is there, we can find the ratio of sine of n, because we are given that the sine of n is the opposite over the hypotenuse, and the opposite in this case is given as 8 over the hypotenuse, which is the hypotenuse in this case is given as what? As 17. So it's going to be 8 over 17 like that. So now we've got the ratio of sine. So as we can see, the Pythagoras theorem, there is a part where it plays a role. There is a part where it plays a role, especially in calculation of the third side, because trigonometric ratios, they limit you to a certain point. But now Pythagoras theorem, it has to be used in order for you to calculate whatever that you're going to be given, which is the third side. Then you use your trigonometrical ratios to calculate whatever that you have. That is the same question as number 2, where they need us to calculate the value of tan C, which is the angle C that we have here. So according to this angle C, we have to name our sides. This is opposite to C. So there we have got the opposite side. This one facing 90 degrees is the hypotenuse in this case. The angle C and the 90 degrees, they are sitting on the same line. They are adjacent to each other. So in actual sense, in order for us to have the ratio of tan C, remember from our ratio of soccer, TOA, in this case tan, it's opposite over the adjacent. So we're supposed to have this as the tan of C is equal to the opposite according to our ratio, according to our formula here, which is opposite over the adjacent. Now, if we check according to this triangle, we do not have opposite. We have the adjacent, yes, but the opposite we do not have. So what are we going to do? We are going to calculate this according to, and this is in terms of K. As we can see, this is given as 5K centimeters, 5K centimeters, 4K centimeters. So we're just going to calculate this in terms of K. Since you know that your answer is in terms of, these sides, they are in terms of K. Just use the numbers, then you know that your answer is going to carry what? Is going to carry a K, so that you do not have confusion. All right, remember, we are supposed to apply the Pythagoras theorem to calculate the third side, because you're given two sides in this case, and you need the third side. So you're going to apply the Pythagoras theorem. The hypotenuse squared is equal to the square of the two shorter sides, which is the sum of the square of the two shorter sides, this being the hypotenuse. And our hypotenuse is the longest side, the one that faces 90 degrees, and that is 5K centimeters. Like I say, just take it as 5, all right, which is equal to A squared plus B squared. That is the shorter side, which is these two sides remaining. So one of these sides is going to be A, so I'm just going to take 4 squared plus another one, which is the one that I want to calculate, which is the opposite, which you can write as OP from this point to this point. It's given as OP, so you can just write as OP squared. All right, so that's it. You can calculate the value of OP, which is the length of this side, or you can write it in terms of C, whatever that you want, but you can write as OP. So that's 5 squared, which is 25, is equal to 4 squared. 4 times 4, which is 16, plus OP squared. So you're going to transpose 16 to the other side. That means we are going to subtract 25 minus 16 is equal to OP squared. Remember, that's an equation that you are now having. You are now solving an equation in that case. All right, so 25 minus 16 is simply going to give us 9 in that case. All right, so that will be a 9. 25, we subtract here 25 minus 16 like this, which is going to be a 9. So 9 is equal to OP squared. To determine the value of OP, simply introduce the square root in this case. So the square root of 9, which is a 3, or you can just use your calculator, the square root of 9, that will be a 3. And this is length, so you're going to take it as positive. So that means the length of OP in this case is going to be given as 3K centimeters, as we are given here these values in terms of K. So this is going to be 3K centimeters, like that. All right, why are we calculating this OP? Remember, it is because of the formula that we want to use for tan. It is limited to that opposite. We need the opposite. And now that we have the opposite, which is in this case 3K centimeters, we are going to have this as 3K over the adjacent. In this case, we have the adjacent, which is 4K in this case, like that. All right, so that's, we can leave your answer like that, or you can even cancel out the K and just write your answer as 3 over 4, which is one and the same thing. So that is the value for tan C in this case. All right, so I want you to try this question, which is the last question that we are having. On F, they are saying determine cos L and cos B. So you're going to determine your cos L. As you can see, it's the repetition of what we've been talking about. You find your sides in case if this side is needed. All right, but according to L, let us just try to assist each other. According to L here, this is opposite. All right, this is the adjacent. All right, and this is the hypotenuse in this case. So the cosine of L is direct. This one you do not need to even calculate this side, because remember, cos is adjacent over hypotenuse, and you already have adjacent and hypotenuse. So this one, there's no need for you to calculate this. All right, then the cosine of B, according to this B, we have the adjacent, but we do not have the hypotenuse. So on this side, on this triangle, you are forced to calculate this side using your Pythagoras theorem, because you are going to need the hypotenuse in your formula for the cos. You have the adjacent, which is fine, but you do not have the hypotenuse. So I want you to calculate that. Then they are saying, what do you notice? So you're going to check what is going to happen between your answers about the cos of L and the cos of B. And what can you deduce about the two triangles and why? What is it that you're going to give as a conclusion about these two triangles? So it's going to depend with what you're getting on your final answers. Are you going to have the same answers for cos of L and the cos of B? Are you going to have the same ratios or not? So I want you to try this question, work on it, so that we can talk about it in our next class, in pending that there are questions on it, but if you fully understand, then that's okay. Let us continue to revise now, working with question papers that can actually help. You have so many questions of this nature that you can have from your question papers. So all you just need is to go through your question papers, revise along, and see how do they ask the questions. That is how you can learn to attempt any typical question of this nature of our trigonometrical ratios in that case.